Alrighty, focus, focus. Today's science lesson is all about static electricity and the charge that we get from that static electricity. So, we are going to do an experiment. The directions for our experiment are in your science workbook on page 57. What is it?
Page 57.
What page?
57.
So online friends, go ahead and flip to your workbook, page 57, so you can see it better. You guys, we're going to make sure that we have all of my materials, okay? So, what is my first material? You can check them off as I show you if I have it, okay? What's the first material? Check. What's my second material? Check. Third one?
Paper plate.
Got it. Check. What's the next one? Okay, my paper confetti is right here. I got it. It's just on a little plate. It's really just hole punched construction paper. But it's paper confetti.
Oh.
I'll show here. I'll hold the baggie up so you can see what it looks like better. This is what my paper confetti looks like. So check.
Check the price
Ooh, not pipe, but piece of.
cotton cloth.
Okay, this is my cotton cloth. If you are wearing a shirt that's kind of like a t-shirt, a regular t-shirt, not a slick one, just a regular t-shirt, that would be cotton. Or girls, if you've got leggings on that are not the slick kind, but the soft kind, that would be cotton. Pass. Picture your regular plain old t-shirts that are not like athletic ones, just regular t-shirts, that's cotton. So that's what this feels like. Regular cotton. Okay, yep. Like Eli's, Jade's, Addison's, my goodness. I love being interrupted, said no third grade teacher ever.
Okay, if you love it, then why
Stand up if you think your shirt is a regular cotton
I
shirt.
don't know what cotton means.
Your pretty's cotton. You have to Hendrix, yours is slick. So go ahead and sit. Your sweatshirt would be cotton. Emerson, yours looks like a slick athletic one, so that's not.
Mine's not.
The rest of you? Yep. Okay, good. Sit. That's what this cotton material is like. So it's kind of just a soft, kind of fuzzy, kind of smooth, okay? What's my next piece of material?
Paper towel.
Okay, I've got just a piece for my paper towel roll. Okay, so it's a little bit quilted, but papery. What's the next one? Instead of a sock, I just have acrylic fabric. Acrylic is definitely smoother,
Like this?
softer, more like your athletic ones. But picture like your socks that are really stretchy.
Oh, these?
Those would be acrylic. Okay.
This is an acrylic shirt.
Yep.
Can I see one?
Okay. Class. What's my last material?
Piece of wool sock.
This material is wool. However, I might use my sweater today because it's got a little more texture and wool. So go ahead and we're going to read. Those are all materials that I'm going to be rubbing on my balloons and charging those balloons up with energy. So remember when we talked, when you rub your hands together, they get warm? And that's because that friction is building up energy. What's it building up? And this energy is in the form of heat. Today,
Who just farted? They made fart noises. I know.
Today, the energy that we're going to be building up on these balloons is actually electricity, and it's a special type of electricity. Static electricity. What type of charge are we building today?
Static electricity.
Look at this top question in your workbook on page 57. At the top of page 57, there's a question. How can you observe balanced or unbalanced forces? So the first thing that you're asking yourself, you're reminding yourself, hey, what is a balanced force? Who remembers from our last science module? If the forces are balanced, what do we know about it, Dax? They're the same, so are they going to move?
No.
No, if they're balanced, they're equal, they don't move. It's like neutral, okay?
Neutral.
What about unbalanced? Are unbalanced forces equal, Olivia? No, so what do we know about them?
One's like on, down,
Or one might be stronger and the other's. So what happens if they're unbalanced? They don't stay the same. They're no longer neutral. They're different. So when we talked about using forces to push or pull, when they were unbalanced, what do they do, Eli? Instead of standing still, they move. Today is a little different. Hold on for one sec. Today's a little different. Instead of necessarily moving, they might move, but when these forces of static electricity get unbalanced, we're going to get that charge, okay? And you're going to be able to see it happening, and I'm really excited to show you guys. So, before I do show you, I want you to make a prediction. It says, what occurs when the charges between two objects, like a balloon and my confetti, are unbalanced? We know if they're balanced, they're neutral. What do you think might happen if those charges get unbalanced? Right now, write your answer on the lines on page 57. All right, third grade, let's hear your predictions. What do you think is going to happen when the charges between these two objects are unbalanced? And really, the two objects that we're dealing with today are balloons and confetti. You already know that. So what's going to happen if the charge is unbalanced? Jade, what did you think? Ooh, maybe it's going to zap you, or maybe the balloon's going to pop. She had two predictions. Did anybody else have those same ones?
Yes, I did.
Oh, okay. Who had a different prediction other than the balloon popping or something shocking you? Ellie?
It might do nothing, but you never know.
Maybe it's not going to do anything. Okay. Landon, what do you think?
I think it's going to move far away. And
What's going to move far away?
the balloon.
The balloon. So when we are writing these predictions, make sure you're specific with that instead of saying it, because we've got confetti too. So go ahead and change that. You think the balloon is going to go far away. Okay? Any new predictions? Maddie? Oh, so you know we've got those fabrics and you think they might stick to the balloon? Okay. Jade?
So, if your hair is around by the balloon, it might make your hair.
Maybe it's going to make my hair stick. I think I should find out what happens.
Yes.
Okay, we are going to read through step by step. And I've done some of the steps to speed it up for us. But we're going to look on page 57. It has the step by step. So who wants to read step numero uno?
Okay.
Oh my goodness, that was big sauce. Step numero uno.
Step numero uno.
Riley, what do I need to do first?
Label the balloons A, B, and C, and E below each balloon and height.
So I did that. You can't tell when they're hanging here, but like this is A, B, C, D, and E. So they're already labeled, they're blown up, they're tied. Step one, done. Numero dos. Oh, that's three. Numero dos.
Numero dos.
Maddie, loud and proud. Confetti. So friends, they just said that this balloon A is our control. When we're doing experiments in science, the control is a thing that you don't change. What's the control? It gives you something to compare to. So this is going to be our balloon that we don't do anything special to. That way we can do different things to the other balloons and compare them to our control. Capiche? So this is my control. And Maddie's step said, hold it close to the confetti, but don't actually touch the confetti. So you guys watch and see what happens here, okay? So I've got my confetti on a plate. I'm going to hold my balloon close to the confetti, but I'm not actually going to touch it. Did anybody see anything happening?
No.
So what happened?
Nothing.
Nothing happened. You're going to go ahead and record that on the back side. Turn your page. So it says sample A. That's this balloon A, our control balloon. Your observations. What happened?
Nothing.
So in that box, you can write nothing happened.
I spelled nothing.
How do you spell nothing? You write no and thing.
No.
So no is N-O.
No.
And then thing would be
Thing.
I-N-G. No thing. It ain't no thing.
I know.
So again, you're putting this in the table on page 58. Where are you putting it? Sample A?
No, I know.
Now, the next step on our experiment, step 4, says balloon B is going to be our cotton sample. Okay? So for balloon B, that means that I need to rub the balloon with cotton cloth. So I've got my balloon, I've got my cotton. We're going to rub it for 20 seconds. Okay? To make sure that we're consistent, we're going to do 20 seconds on the actual timer here. Let's do 30 seconds. I want to make sure that I get it nice and charged up. So, 30 seconds is on my timer. Are you guys ready for me to rub? If you even want to push my start button.
3,
Come in.
2, 1.
So I'm going to rub this spot on my balloon for 20 seconds. 30 seconds actually. And what do you suppose is happening
Stick to
as
your hair.
I'm rubbing this?
19, 18,
What type of electricity, Kevin?
16, 15, 14,
I think this friction is building a charge up on my balloon. Did I have a charge on my other balloon?
7, 6, 5, 4, 3, 2, 1. Stop!
Okay.
Nothing happened.
So now I've got to hold this next to my confetti. Watch. See if anything happens. Oh.
What?
Okay.
There's so much electricity.
Okay. So on your chart, record what you noticed. This was I know. I'll clean them up later, friends. This was B. For B on your chart, sample B, the cotton one. Record what happened.
It's worse.
And be specific. Don't just say it sticked. What sticked? We've got confetti and balloons. What happened to the confetti? It didn't just stick to it. It happened. It was sitting in a plate. What did it do? The balloon like sucked the confetti up to it, right?
Like so much electricity. It's like the balloon sucked
Did
up
you?
water.
Focus, focus.
It was like it sucked up water.
Whoa. Try again. Focus, focus. Did you notice that at first the pieces of confetti just kind of started to slowly like stand up, and then all of a sudden they were like, Some of them even like clung together. It was almost like they were magnets, but are they magnetic?
No.
No.
Put it close to your hair now.
Okay.
Put it close to your hair.
Step 5 on my experiment is balloon C. This is my paper towel sample. So we're going to do the same thing. We're doing 30 instead of 20 seconds, but this time I'm rubbing my paper towel. So my paper towel looks like this compared to my cotton. Which one looks like it would have more bumpies and more friction?
That one.
This one, I think this one looks like that too. However, it is like a nice Bounty brand towel, so it's pretty soft for a paper towel. So be thinking which one if you think it'll be the same, if you think it'll be different. So you're watching. Skylar's gonna hit my start button.
3, 2, 1, go.
So again, we're building up a charge. Remember, did my control have a charge at all? Oh, gonna sit down. Oh, my friend, Skylar's the only one who touched my timer. The rest of you are set it.
I'm gonna start counting at 10.
Did my A control balloon have a charge at all?
No.
Did my B cotton balloon
10,
have a
9,
charge?
8, 7, 6, 5, 4, 3, 2, 1, stop! Happy New Year!
Let's see. Everybody's got to be sitting so you can see.
I know it's gonna do. I know it's gonna
There's
do.
my confetti.
Probably gonna push them away. Woo! They're playing.
What do you think? More or less the same?
More. Same. More. Same.
Pretty much the same. Pretty much the same. It maybe happened a little faster. I'm not sure. It was pretty much the exact same, I think.
I'm just gonna write same in that box.
Another way that you can record that.
Same as C. What is on there?
Clase, clase.
Same as
So when you are recording things in tables like that,
I wrote same but
or you're writing things down, one way that you can do same is like on a chart. Let's say that you recorded like step A, and you wrote like a whole long sentence. You said like, the confetti
did not.
stood up and
Nothing happened.
And nothing happened.
shot up to the balloon
Shot up to. Well, nothing happened to A.
to stick to the balloon.
And then.
And that's a lot that I just wrote. If the exact same thing happened, instead of writing all those words again, but you want to say like, okay, it was the same. Instead of writing the same, another thing you can do is you can put quotation marks and say like, okay, copy that.
I just put.
That's the thing that some people do when they're taking notes.
I just put Sam as B.
But we are ready for step numero 6. This says balloon. D is our acrylic sample. Which one is this? That's the smooth, silky fabric, okay? This is really soft, it's really smooth. A lot of your athletic gears, those are like slicker. Mine's not quite as slick, mine's a little softer, but that's the material, okay? So, balloon D is my acrylic. This is that soft, silky, smooth fabric. Skylar, you ready?
3, 2, 1.
Skylar, can you just sit down?
I already have a curl hair that's stuck to the balloons, that's fun.
You're cleaning
That's
the
not very-
balloon.
Silky enough, it's harder to rub because it wants to pull up on itself.
You're too high, Gunner. It's now at 10,
10, 9,
8, 7, 6, 5, 4, 3, 2, 1.
ready?
Blast off.
Let's see. See how it is. Got my confetti? Got my balloons?
Yeah.
Oh.
Way more.
I think way more of that shot up. Look at that. So you could say more confetti shot
I
up
said way more.
when you're recording on your chart. This was balloon D. More confetti. And do you guys think that happened at the same speed? It was kind of faster and like more. It was more all at once. The cotton one, I feel like it kind of trickled. Like a couple started to connect, and then they had like strings of confetti.
It was like
This one was all just like.
straight pencil.
That was pretty cool.
Now,
It's because
Okay.
there's so much electricity, it's gonna pull it.
are you gonna do your hair now?
Because it's so strong.
Let's see what E does now.
Oh, cough, cough.
What is E gonna do?
He is the wool. I thought I was gonna use my sweater, but then I realized it'd be harder to like. Maybe we'll do both. Maybe we'll have an extra balloon. Okay. So E is wool. You ready to time me, Skylar?
3, 2, 1.
Oh, this is a smaller piece, though. It's gonna be harder.
Mitchell, I think to do it for 2 minutes.
It does, doesn't it? 2 minutes. So that means you're gonna click that 4 times.
4 times.
2 minutes is a really long time.
Where does it say that?
Good catch, Dave. I was supposed to do the acrylic one for 2 minutes too.
2 minutes.
So click up top, click restart. There you go. So then we're going on a second set of 30 seconds, so let's look at this to 1 minute.
Whoa, look at it.
You guys, it's already collecting fuzz from my, just from this. Maybe I'll do the first minute with their wool piece and the second minute with my sweater. Because this time's a tinier piece, it's harder to get.
Should I not restart it then?
10, 9, 8,
We'll
7,
restart again after this.
5.
We still have to go a whole another minute, so Skylar's gonna hit restart again for another 30 seconds. Good? Alright.
Disco party.
What if it collects it from your sweatshirt?
It probably will. There's
It's probably
like
cleaning
buttons and
it.
stuff.
It's probably cleaning your shirt.
Oh my gosh, my balloon. I feel like I never caught my balloon.
No, literally, there is flies coming out.
On my sweater, yeah.
I think that's long.
4,
3,
He's
2,
got it.
1.
We still need
Resume.
30 more seconds to make it to 2 minutes. This one feels like forever now. Ugh.
It's sticking to your shirt.
No, it's not. Oh, it's making my shirt. There's a. I see what you're doing. Holy cannoli, this is a lot of charge.
I think it's going to like.
Are you guys all sitting? Ready to see? Ready to see? Ready to see? Sit down. 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, you ready to watch? That was a lot longer to charge it up. Check it out.
Whoa! That's like the same.
I think it was kind of the same as the last one, too.
Same.
Are you not surprised?
Yeah,
Surprised?
way faster.
it's sticking way more.
They did. It is more sticky. It's harder for me to get it off of the balloon.
Yes,
No, but that's something good to know. So like they're really clung to the balloon this time. They really wanted to stay stuck to the balloon on that one.
Yeah.
Okay, so here's the deal. This says
Can I go to the
afterwards it says, hey, let's analyze our data. So I'm looking back at my workbook page. Right now, buddy, we're still in the middle of an experiment.
Rylan,
Right.
don't stand on the chair.
Friends, it says analyze our data. And what that means is we gotta look at, hey, what did we record? What actually happened? And then we have to think about what that means. Scientists analyze things all the time. That's after our experiment. So, they say circle, you guys can't see my page. Circle the sample that had the largest change. Which one do you guys think made them the most? Cotton, acrylic? I honestly think the acrylic did too, and that shocked me because it was the smoothest, softest material. So circle up top, circle your acrylic one.
I think it might be the wool though.
You think so? Circle which one you think it was the most.
It could be both.
And then- Oh,
Acrylic.
Can we circle both?
No. Yeah, circle both.
They did nothing.
which one had the smallest change? Which one had the smallest change? Addison?
A.
Well, yeah, the control had like no change, so absolutely. Well, the air conditioner's kind of blowing the balloons. So that's fine.
I can't see what you drew.
So it's underline the sample that had the smallest change. All I'm doing is following the directions. Is it important for us to read the directions?
I picked it up from way over there.
Is it important to follow the directions?
Yes.
Absolutely.
What did you name the balloons?
It says now, describe
What about balls? Oh, man.
Focus, focus. Oh, I'm hearing hums, so I know you guys can answer. Focus, focus. They want us to describe the sample that had the largest change. So whether you marked acrylic or wool, you're going to have to use your words to describe what you see. What happened?
I saw confetti.
I love that. The confetti shot up. You guys are writing these also. And it could be in your own words, but the confetti shot up, and what else did it do? After it shot up, it didn't just like fall back down.
And stick.
Stuck. Stuck to the balloon. The confetti, that's an I. The confetti shot up and stuck to the balloon. So this next one, this is the one I want you jotting on your own. It says, hey, how did your observations, this observation, and the things that you put in your charts, how does that compare with your prediction from page 57?
Not good.
You might say things like, my prediction was correct. I thought this would happen, and this did happen. You might say, I thought this would happen, but it was totally different. This actually happened, right? How did your observation compare? This is the part that I'm going to be checking as your ticket to lunch and recess today. Online friends, this is going to be the second part of your slides today. So, good luck. Make sure that you write and complete sentences. So make sure each sentence starts with a capital, ends with punctuation, and those sentences have to make sense. They're complete sentences, okay? Good luck, guys.